Hello, Keith Rucker here at VintageMachinery.org. Guys, today we're going to be working on a project out here in the shop, and I'm going to be installing a digital readout on my Monarch lathe. Now, this is something I've been wanting to put on this machine for quite some time now, and I just haven't done it. And I finally just broke down and ordered myself a kit to come in here, and we're going to put this in. So first off, the kit I bought was from Dro-Pros or DRO Pros. You can check them out on the internet at DROPros.com. I'm going to say right now that this was something that I purchased. This was not something they gave me. I'm not getting any kickbacks from them whatsoever. I have been a satisfied customer of them for some time. I have one of their digital readouts over on my vertical milling machine. I've probably had it installed for 12, 13 years, and it's performed very well. So when it was time to get another digital readout, I decided I would go with theirs again. It's very similar to the one I have on the mill. This is a lathe specific one, whereas the one on my milling machine is a mill specific one. So some of the functions are a little bit different, but I'm familiar with this particular one, and again, I've been very happy with them. Let me kind of zoom you in here and show you what all you get, and we'll get started doing this installation. So when you're ordering one of these, you order it based on the size of your machine. If you go to their website, they will tell you how to size your machine, and they have different kits with different length scales in there, depending on what machine you're installing them on. I don't remember the exact measurements of this one. It really doesn't matter, but you need to basically measure the travel of your cross slide plus the travel of your carriage, and choose an appropriate kit that has the scales in there with the range that you need. And again, all the information on how to size one is up on their website. This particular kit that I got for this one, it was, I think, around $1,100, $1,200 range shipped, and basically it's because I have some larger scales. So these long pieces here, these are the magnetic scales that we'll use. Basically, we're going to mount this to the machine. They have a reed head that slides across these like such, and it basically picks up your measurements as on those and sends them to the readout. So you get an extremely accurate indication as to how far you have moved different things on your lathe. Yeah, you can use your dials, particularly on the cross slide. On the carriage, there really isn't a good measurement dial in there. A lot of times I'll put a dial indicator on here the way it is now if I need to make a measurement going in and out. The biggest one is in this axis here, but we have got everything we need here, and we're going to get this thing installed. So let's get at it. So we're going to start by mounting our scale here on the cross slide. But before I do, I just want to explain something about these kits that you can put, digital readout kits for different machines. In the case of this, it's not like I can just call up and say, hey, I have a Monarch 16-inch Model K lathe, send me a kit for that lathe. What you do is you buy a generic kit and you fit it to your machine. Because of that, you're pretty much always going to be having to make some brackets and mounting equipment and whatever. Now, when you buy the kit, I didn't show it when I showed this, it comes with some mounting, kind of generic mounting hardware, but in most cases, you're going to have to do a little bit of being creative and figuring out how to mount that stuff to your particular machine, and you're probably going to have to go make some parts to do that. They kind of take into consideration that most people are mounting a digital readout kit on a lathe or a mill. You've got some metalworking equipment to work with. So understand that may be a limitation for some people, but for most people I think it's going to be fine. And that's what we're getting ready to do. Now we are using magnetic scales. Some of your older digital readouts use glass scales. The magnetic scales I think have several advantages over the glass scales. They're not nearly as fragile. The glass scales can break being one thing. They're just as accurate. In fact, in many cases, they're even more accurate. And the really nice thing about these magnetic scales is that you can cut them in your shop to whatever length you need them. So when you buy a kit from Dro-Pros in this case with their magnetic scales, you will typically get a scale that's longer than you need, and you're just going to cut it to whatever length you need, which is a really nice feature to be able to do that. So let's zoom in here and talk about getting this measured, figuring out how long we want to cut this scale, and how we're going to get it mounted to our machine. So step one here is I want to pull my cross slide all the way back. So I've got it pulled back as far as it'll go. This is the maximum travel. And I've just made a mark on here on both the table and the cross slide. And what I'm going to do now is we're just going to crank it all the way forward and measure and see what that distance is. This will be the maximum travel that this machine will do. And there we go. That's pretty much it. So I'll put my tape measure on the mark up there on here. It's 8 inches, almost exactly. So we're just going to call it 8 inches. I'm going to pull this on back. Now on the Dro-Pro's website, they have a little worksheet you can hear for cutting your scales. And the first one here is to figure up, again, that the maximum travel of your cross slide, which is 8 inches. And to figure the minimum length that this scale needs to be, you need to add 4 inches to that. That gives you room on each side for the reed head and the mounting brackets and so forth. So we know that we don't want to cut it less than 12 inches. The next thing we need to do is figure out what the maximum is. And in the case of my machine, we're going to probably have to make it a little bit longer just because of the way the mounting is. I'm going to show you what we're talking about here, and we're going to figure out how long to cut this. But you definitely want to make sure that you check and make sure that you're not cutting this thing too short. We want it to be under 12 inches. That's the absolute minimum. Now on the cross slide, we typically want to have our scale mounted on the edge of the cross slide, kind of going like this right here. We'll have the reed head mounted to the bottom, and basically when you move the cross slide, the scale will move. Got to get it moving here. It'll move with the cross slide, and your head will stay stationary, and that will allow that measurement to take place. Now, on this particular lathe, this is an older style lathe, and this is very common on your older machines. You know, they were not designing these to mount digital readout scales to. So in this case, I got this kind of hump coming around here where my compound slides around. It sticks out from this base. Most of your modern machines, or more modern machines, are going to have flat surfaces over here where you can just literally mount that right to the cross slide. But in this case, I'm going to have to make some little standoffs so that it will hold this out so that we can clear this compound right here, if that makes sense. So we'll be showing you that in a minute. Now I know that, again, we come in all the way. My reed head's going to be down here. So, you know, I'm going to have this thing sticking out, you know, at least to somewhere along in here where that reed head can come over and actually make a good measurement. And because of the way we're going to have to mount this, I really need for the back end to be beyond this little jut out, which is probably a little bit longer than what it needs to be. And ideally, it'd probably be about right there, but I'm gonna have a standoff on this side and a standoff on here. We're gonna actually have an extension that comes past this to mount it in the rear, and we will then mount the scale up to it. It's gonna be a little bit longer than what it needs to be. We're gonna have more scale on here than is needed for the reed head, but that's just kind of the way we're gonna have to do it. So this little piece juts out about a 1/2 inch from this casting up to this front piece. I've got a piece of steel here. This is a 1/2 inch thick, 1 inch wide, and my scales are about 1 inch wide too. So this is going to be a nice, you know, just a extension to come off of this to mount it to. So what I'm going to do is we're going to cut a piece to fit in this area right here. We'll probably drill and countersink a couple of holes for some cap head screws to go into it, and we'll also drill and tap a hole to mount the scale to. And I'm going to go ahead and get this front side on here. Once we do that, we'll know exactly where that's going to mount, and we'll know exactly how to cut the scale and get the other side on. So let me go get this piece cut, and we do a little quick machining to it to make that nice little bracket. So I've got my block set up here. We need to drill and counterbore a couple of holes. What we're going to do is just use a 1024 socket cap screw. It'll just drop down in 2 holes here. Then we're going to drill and tap a hole in the center. I think that's 4 millimeter or whatever pitch. I'll double check and get that one, and that'll be what we actually mount the scale to. I'm just going to eyeball this hole. It just needs to be, the dimensions on this are not that critical because we'll use this as a template to drill and tap the holes in the other piece. So here we go. All right. I'm going to swap this out for my counter bore. Let's slow that down some. And this is just going to drill out a place for that cap screw to fit down into. Let's see what we got here. Just want it to clear. There we go. That's below the surface. And we'll go ahead and do the other one, other side. And again with our counter bore, make sure that's deep enough to clear. It is. All right. Let me get my drill and tap for that metric thread, and we'll put that right in the middle. I think I said 3 millimeters. It's actually a 4 millimeter 0.7 hole we need in there for a tap. So I got the appropriate drill bit, whatever that is. Had it in my drill drawer over there. So we'll go ahead and drill that. I'm just going to drill it as a through hole. We'll go all the way through the part. And put a little tapping material in here, just a little bit of lubrication. This is some anchor lube. And I got my tap set up here. I got a tap follower up top. This is just a little spring-loaded piece. It's in the same axis that I drilled the hole in, so that's going to make this tap run nice and straight. And we're going to do this by hand. Probably could have power tapped that, but it's just such a small size. I'm worried about breaking a tap in there. I'm just going to do it by hand. And that seems to be cutting pretty good. All right, I'm not feeling any more tension there. It's going through, which tells me I'm all the way down. All right, we'll back this tap out. So with our standoff made, I'm going to put it over here onto the thing, onto my piece, and I've noticed I got a little scale up underneath this, just a shim to make sure that doesn't drag on the bottom. Now I got to drill this, and my drill bit's not long enough for my drill, so I just got a little adapter here. This is just a piece of steel. I turned it to fit in the chuck on this end. I drilled it with the drill down here, put a set screw in there, and that's just to kind of get it started there. And I'm just going to put it in there. That should give me a starting hole. It does. And we'll go ahead and drill this and then tap it to take that set screw, or that socket cap screw. I'm just kind of seeing how deep I am. That's probably enough. I got a long tap handle with a 1024 tap in there, and we're just going to go ahead and tap that down to the bottom of that hole. And that feels like bottom. I'm going to pull it out now, and we'll use a bottoming tap. A bottoming tap will make threads all the way to the bottom. This is a taper tap, so it's for starting a hole. If you can't go all the way through a hole, this tap here has threads that are all the way to the bottom, but you can't start it with this because it's got to be tapered to get started. But this one will get us good threads all the way down to the bottom of that hole. So we'll just go ahead and turn it on in, that last little bit in the bottom there, and that should be good. Now I've got a transfer punch. This is a punch that's the same size hole as that center. It's got a center punch on the end, and we're just gonna, whoops, tap that in there. That should give me a nice dimple. I'm going to go ahead and drill and tap this one, and we can go ahead and get that one installed. So I've got my mount bracket mounted, and next thing I'm going to do is I'm just going to put this scale in place just temporarily here, so I can get a good measurement on the other side of exactly how long I need to cut that next piece and to cut my scale itself. All right, that'll be good for now. I'm going to go ahead and pull this on all the way out. So that tells me about where I need to be here. Again, my reed head's going to go in this general area here, so we can probably cut it off about even with this way out here, and we'll be fine. So what I'm doing now that I've got this on here is I'm just verifying that this is where I want to cut it. It's going to be a little bit longer than what it needs to be, which is perfectly fine for the application at hand. But we need to cut a piece of metal back here that we're going to mount all this to. So I think what I'm going to do is go ahead and cut the scale, and that way I can go ahead and put my end cap on, and I'll know exactly where it needs to be, and we should be good to go. Now to cut this scale, there's nothing magic about it. I'm just going to use my Morse Metal Devil 14-inch chop saw here, and we're just going to cut it right off. There we go. So I've just got this up in the vise. I put some soft jaws in here. These are some 3D printed jaws that my buddy Chuck Bommarito, Outside Screwball on YouTube, had made and sent to me. And again, there's some holes in there that are just extruded in this aluminum, and that's what we're going to be basically tapping down. And I'm using a 3mm 0.5 pitch tap here to tap these. We'll get both of these tapped in. That's probably plenty deep, and put that end cap back on. And here's our end cap, goes on, and there's a couple of socket cap screws that thread in there and hold that in place. Just got the top one. There we go. Our scale is cut to length and should be ready to install. All right, guys, let's give you an update of where we're at. So I got the first block on. You saw that. I went and made the second piece back here in the back, and I quickly discovered that I had an issue because the way that scale was, when it was going to hit back here on my taper attachment. So I had to raise it up to get it where it would clear. In order to do that, I had to actually weld a little tab on the tops of these two bars and re-drill and tap a new hole in here. So again, you know, it just requires a little bit of fabrication here to come up with your own brackets and mounts to mount these things, but no big deal. A little scrap metal laying around the shop, and we are moving forward. So these are just some shims that I'm putting up on some spacers to hold this thing up. I'm going to go ahead and mount this side over here. All right. And what I want to do is I want to mark where I want to drill and tap the hole in back here in the back. So again, transfer punch. We'll come in here and we'll punch that. I think I'll walk around to the back side of the lathe and do that. So I'm just going to tap that. That should, yep, I got a nice mark right there where I need to drill my hole. So I'm going to take this back off. I'll go over to the mill, drill and tap that hole, and I think we'll have this mounted where it needs to be. So next we need to put our reed head on, and the kit comes with this little block here that the reed head mounts to the top, and when you mount this directly to the carriage, it's at the right spacing out to just work perfectly. Unfortunately, again, because we had to put these spacers back here, I'm going to have to shim it out. So I took a block of steel, and that's just in between these pieces, and it gets it at the right thickness. Now, there are some grub screws or set screws in here that allow you to adjust this, tilt it in and out, basically, and then you just snug it up, and then you can move it around a little bit to get this thing positioned just right. There's also slots here to move it up and down, so it's kind of adjustable in all directions. And later on, we're going to put a shim behind that and fine tune that. First, I need to make sure this is running perfectly straight and everything else. So we got some adjustments to do later on, but I'm just kind of showing you where we're at. I've already got my holes tapped, drilled and tapped down here. So let's start by putting the reed head on, and we just got a couple of screws here, socket cap screws that go in here like such. Next, we'll take our little spacer block that we put back behind there. I got two set screws, or not set screws, but the socket cap screws that go into these, and we'll just get both of those started by hand. Again, it's adjustable once we get it up on here. I'm just going to go ahead and snug it up. All right, that is in place. And again, we'll fine tune this and adjust it later on, but what I want to check right now is to make sure that my range is good. So this is all the way in. See, we got a good almost inch there of clearance. Bring the carriage back the other direction. And we got a good half-inch clearance down there. So I think we're good. Our reed head is going to work just fine right there, and we should be in good shape. All right. Next thing we're going to check here is to make sure that the scale is running parallel to everything on the machine. Because of these spacers in here, it could be in or out a little bit. So I've just got a dial indicator on there. I zeroed it in. I'm all the way in one direction, and we're going to roll down through here, and if you look and see, that indicator is dropping off some, which tells me we need to adjust that scale just a little bit. The machine is running parallel. I know that. We checked that when we rebuilt this machine. It's just the way this scale is sitting on here, and it's about 22 thou. And if you look, I need to pull this out 22 thou to get it to line up in that direction. So it's easy adjustment. We will loosen our set screw, or excuse me, not a set screw, our socket cap screw in the center here. So we'll start, we're going to loosen this screw right here. And again, there are 4 set screws around this, and I'm just going to start cranking on these, and that should move that dial out, although it's looking like it's going the other direction. Here we go. So see, as I'm putting these screws in, it's dialing that back up towards 0. I want to go more or less to 0. I need to loosen this up a little bit more. All right, we're re-zeroed there. It moved just a touch. I'm just going to re-zero that. We'll go to the other side again. And it looks like we're still dropping off about a thou and a half maybe. So we'll see if we can adjust that on the back side. Before I do any more though, I'm going to flip my indicator up. We're going to do the top of the scale and make sure we kind of got it going in that direction in case we need to make any coarse adjustments which could affect this other measurement. Let's check this height coming back. It seems like it's running within a thou, which I think that extruded aluminum probably has more air than that in it, so I think we're good. And let's recheck our other face here. I think we can live with that. It moves a little bit down on the end, but again, it's a thou. Probably the air of the extruded aluminum. Good enough. The final adjustment is to get the reed head set properly. And just like on these other things, we've got the two screws that tighten it down, but there are 4 little set screws in there that can be used to jack this thing and turn it around in different directions. Now in the kit there comes a little plastic shim. Notice I've got that behind that. You want it to be just tight, but also where it will move freely. I'm going to pull it out now, and that reed head should be set just right to this machine. Everything should be tightened down, and I think we're ready to move on to the back magnetic strip there, the back scale, and get it mounted very similar to this, although I think the back one might go a little bit easier. So moving on here, getting ready to mount the scale on the back side of the lathe. This is for the long side, and same type deal. We got a reed head here that needs to mount to the carriage to move back and forth. And I actually started with this because this is going to be the more difficult part of how I'm going to mount this. Now ideally you would just come onto the back of your piece here, and that comes with everything you need to really adjust it and make a bracket to hold this reed head. But because I have a taper attachment on my lathe, it really isn't practical to use the setup that they provided. You just got all this stuff going on back here. Now, I could have removed the taper attachment. I got a nice machine surface on the back that hangs down here. I could have drilled and tapped some holes in here and put my reed head on there, but that would have required an awful lot of work to remove this taper attachment off of here just to mount this. So I ended up going a different way. I actually had already 2 mounting holes that were in this in the cross slide, or in the carriage. I'm not sure what those were there for, but they were in the lathe when I got it. I'm not using them. I said, you know what, let's use them. So here's what I did. I took a piece of the steel, I made an L-shaped bracket that will mount to these holes right here, and then up underneath the bottom of that I have another piece of metal on the bottom. And if you look, I got it set with 2 screws. The reason I did this as a separate piece is so I could have some adjustment. Again, I put the little jack screws in there, the 4 corners. All right, so a little update here. We got our reader head mounted. We have the scale mounted now. I've already gone in here and adjusted the scale, got everything lined up just right, and it appears to be in good shape. I got my cables kind of tied up. I put some cable straps back here, and I just went ahead and used some wire ties and tied those cables together so they're both basically right there together, going to and from the actual digital readout unit. Now, one thing I want to do here is we've got this scale all exposed, and the kit comes with a cover, and we've cut it to length, and I had to do a little modification down here, cut out a notch for it to fit up over this piece on the end, but no big deal. But there are a couple little screw holes in the ends of these on these magnetic scales, and got some screws in there. We're going to mount this cover that'll just keep chips and stuff from getting on it, help protect that reed head, etc. So let's see here. All right, so that's all covered up now. I've also got a scale cover that covers up this bottom scale, but I've got to do some modifications to it. I'm going to do that later, but we will eventually get a scale cover covering that one as well. But everything's together, so let's go check it out and make sure everything's working right. All right, so I'll just make a note here that I made a little bracket back here in the back to mount this on. I just used some existing holes that were in my machine and made an arm that comes up. It comes with a little swing arm that has to mount to something, but I built that behind it. I'm gonna pull it off when I'm done here and get it painted. I think I'm gonna actually weld some little reinforcement metal on there because it is a little bit shaky, not a big deal. Usually I grab it when I'm typing in up here on it anyway, so I think it'd be fine, but I can stiffen that up just a little bit by making some modifications to it. One quick thing to note is on this kit, it comes with the scales that are on here. On the cross slide, it has a 1 micron resolution scale, whereas on the Carriage, going back and forth, it has a 5 micron scale. And there is a little bit of setup you have to do to get this thing set up. It is set up by default where both of them are reading 5 microns instead of 1. And when I first plugged this thing in, I put a dial indicator on there. I moved it 100 thousandths of an inch on the dial indicator, and I noticed on my X that it said it had moved 500 thousandths. So I'm like, whoa, something's wrong. But I noticed it was a perfect 1:5 ratio, and I did what you're supposed to do that I didn't do is I read the instructions, and there is setup here that tells you how to configure this to read the right scale. So basically going from a 5 micron scale to a 1 micron scale in this one axis. The other one will be on a 5 micron scale. Anyway, you can kind of see the numbers. I'm just moving the Carriage a little bit here back and forth, and that's in inches. This will easily swap between inches and millimeters by the push of a button. You can do that at any time you're in here. Just go between units. It automatically does that conversion on the fly. Same here on the cross slide. Now, there are lots of different functions that this thing will do, and I've got to actually sit down and learn about them. But this is going to be a game changer because instead of having to read dials now, I can look up here and read off of my piece or off of the Dro. One of the cool things you can do is when you're turning something, let's say you make a pass on there and you measure it and it measures 1 inch 537 thousandths. You can actually type in here what the actual diameter is for the cutter that you have on the lathe, and it'll actually read in the diameter of your actual part. So let's say I'm shooting for 100 thou. Well, I can just dial right into 100 thou and it should be right on there. So it's a little bit different thought process of having to, than just normally using dial. It will actually give you a true readout in the diameter you're doing. Of course, if you change tools, that your tool setup is going to be different. I believe you can actually save multiple tools in this thing as well. So if you got 2 or 3 different tools, you can actually zero them all out, and you can change out tool numbers, and it will automatically know where that is in relationship to the machine, which is a really cool feature. So we'll be playing around with this and learning more about it, but it is installed, it is working. Well, there you go, a quick installation video on my Dro-Pro's digital readout installation. All in all, guys, it's not a difficult job to do. I will say that it is time consuming. A lot of little things in here, it just takes time to do it, particularly when you have to start custom building mounts and stuff. But almost probably any machine that you put one of these on, you're going to have to do that. You're going to have to make it work for your machine, and you're going to have to be creative and really think about how to do it. The parts and pieces that come with it, they're helpful, but they're not always going to work in every single application. There are kits out there, manufacturer specific kits. For example, if you have a modern lathe by a certain company, you can probably order a Dro that is ready to slap on that machine, but it's typically going to be a lot more expensive than using one of these more generic kits. So as long as you're comfortable doing a little bit of work on your own, you can really save some money and have a very good tool. This Dro, I'm satisfied that it's going to perform very well for me based on how my other one works over on my milling machine. Like I said, I've been using it for somewhere between 12 and 15 years. It's worked flawlessly, haven't had any issues with it whatsoever, and I know these guys build a quality product. And this digital readout head, while the one on my milling machine is a mill specific, it has the functions in there for a mill. This one has functions in it for lathe. It's basically the same model, so I'm confident that I'm going to have a good unit here. Guys, that's pretty much going to be a wrap. As always, thanks for watching. Please subscribe to my channel if you haven't already. Those thumbs up and comments are appreciated. and we'll catch you on the next video. Thanks for watching.